Hello, in this video we're going to go over a recent OCR maths mechanics question on moments. It's fairly standard, fairly straightforward question with everything being horizontal and vertical, making life a bit easier. So we've got a beam suspended by two pieces of string. It tells us various things about distances. I suppose the key thing is it's not uniform, and it wants us to find the position of the centre of mass. And the other key bit is the tension in C is 3 times it is in D. Now you have a sense that actually the centre of mass therefore is going to be closer to here, because if it were, somewhere in the middle, obviously it's not symmetrical, so never going to be exactly, but there wouldn't be much difference if the weight was in the middle, whereas if the centre of mass was kind of around there somewhere, you have a sense that tension would be more to counteract it there. But let's get on with the question then. So let's put, I've got a little diagram here. So we've got the weight of the thing being 20g. And we're told, as I say, the tension at C is 3 times the tension at D. So if I call the tension at dt, then it's 3t here. Okay, and that's it. I don't think there's anything else involved. It's a little bit of a kind of messes with your head a little bit with the second part, but this part is really that straightforward. Nothing else going on, no extra kind of forces or masses or anything. So it's kind of nice and straightforward question, really. Anyway, and 5 marks as well, so should be doable. Resolve vertically, often a good idea. There we get 4t is equal to 20g. So t is equal to 5g. Very straightforward. Okay, so now we want to find, it asks for the position from A, because that's where it's marked. This is x. In this with moments. Now the thing is, we could take moments about, I suppose, the 2 places we could take moments about many places here and get the answer. Could take moments about B, D, C, A. I wouldn't take it about the centre of mass, but otherwise it's pretty straightforward wherever we go. I'm going to take it about A simply because even though there's 3 forces involved, we've got the distance asked for there is x, so it'll just make all the distances pretty obvious, I think. And so although there's 3 forces in our equation, it'll make life pretty easy, because that's 0.5. And this distance here, that distance there, is 4 take away 0.7. So that's 3.3 meters. Okay, so what we can now do our moments equation. So we have moments about A. So the 2 anti-clockwise ones are these 2. So we have 3t times 0.5 minus, also plus t times by 3.3. And then that's counteracted by this one, which is equal to, so minus 20g times by x. Now t is equal to 3.5 equal 0. I can just kind of rearrange, that's 1.5t there, that's 3.3. So that's 4.8t equals to 20gx. But t is equal to 5g. As we've already found. I don't know what's happened there. Sorry about that, I'm not sure what happened there. Anyway, so that's 5g here equals to 20gx. The g cancels, as it so often does, particularly with moments questions. And so we then are left with x is equal to 24 over 20. X is 24 over 20. Equals 24 over 20, 6 over 5, or 1.2 meters. Okay, so that's nice, easy 5 mark question. So compared to some of the things we see, that is a bit of a gift, I think. Anyway, part B is a little bit of it messes with your head a little bit though. It's only 2 marks. It says a particle of mass m is now placed on the beam at a point where the magnitude of the moment is 3.5 Newton meters about c. Now if it's 3.5 Newton meters, then it's got to be 3.5 meters away along the beam. The only place that that can be is B, because the distance from this distance here, that distance there is 3.5. That distance along there, so it's badly annotated, but there you go. That distance there is 3.5. So the only place that this mass can be, I don't know why they've worded it like this, could be at B. So basically what it's saying is a mass of M is placed at B. I think they've just deliberately tried to make it a couple of quite confusing marks because they don't want to give it away. They probably decided part A was too easy, so they want to confuse us with part B, even though the actual maths involved is not that difficult. So we've got part B. So we've got mg. We've got a mass of m at B, so that the moment is 3.5 meters. Right, so that's basically what it amounts to. Let's just draw it over here, actually. Let's draw it over here, so I've got a bit of space. It talks about the largest possible value of m. So what are we talking about here? Well, if m is too big, it's going to start to kind of rotate. So t is going to kind of be equal to 0 at that point. Because if m is too big here, if we put too much of a weight there, we will it'll start to rotate about here. So I will just give a scenario at point of rotating about D. That will be when the maximum value of m is. So let's draw the diagram there, mg. We've got D here, and that's 0.7. So I could put a pivot there, but there's no pivot there, it's a string. I put T, it's not going to be the same T as last time, so if that bothers you, use a T dash or something like that, but it's going to be a different T. And there's going to be no tension here, T equals 0 here, so on the point of tilting, because it's just about to rotate, but it's still horizontal. So this is 0.7. And then we already know that the weight of the rod, which we've worked out from the previous, oh no, we haven't worked it out, it's told us 20g. Okay, the 20g. And we've worked out that this length from the length is 1.2. So that means because it's 4 meters long and that's 1.2, that must mean that this is 2.8, which must mean that this here is equal to 2.1 meters here. So we can just do a counter. We can take moments about C. They've got these two kind of moments have got to counteract each other. So we have moments about C. We have 0.7 times mg must be counteracted by the 2.1 times 20g, or 20g times 2.1. Let's write it the right way around. I always do force times distance. That's mg times 0.7 equals to 20g times 2.1. Again, g cancels, and 2.1 divided by 0.7 is 3, so the maximum value it can be is 60 kilograms. So any more than 60 kilograms, it's going to rotate. Any less, and we're going to have some tension in C. But at that point where it's on the point of rotating, there won't be any tension at C. So that's what that's all about. Okay, so that's it. Relatively straight up. But B was confused. It's definitely the way it's worded. But part A was nice, straightforward. So hopefully that's useful for you. Okay, bye.